Welcome to Podcast as Code, a show about the operations side of the software development lifecycle. I'm Mitchell Scott.
And I'm Gabe Cook.
Today, we're going to talk about monitoring. But first, let's talk about current events.
So this one just recently happened. On July 19th, the CNCF, which is the Cloud Native Computing Foundation, announced that the Cryo project has graduated to being one of their projects. Cryo is another container backend, so you've probably heard Docker and most likely have heard Containerd, and Cryo is another alternative there. And you know, this is commonly used with Kubernetes. It is a little bit more of an all-in-one solution where Containerd is kind of a few different open source projects working together. But, you know, it's cool that we have alternatives, and it's cool that CNCF has, you know, taken on another one.
Yeah, so Containerd, that one was built by Docker, right?
Mm-hmm. Yep. Containerd is also a CNCF project.
Okay. Who built Cryo?
That one's built by a few different people. It's Red Hat, I think SUSE, and some others.
Nice.
But mainly Red Hat. They're their top contributors.
Nice. It's nice to have options in this space. You know, one project having a dominance in that area is kind of troubling. So it's nice that there's two that are reached like that maturity level. So, you know, you could choose whichever one makes sense. I think all of our clusters were running Containerd.
Yes. Yeah, we are. Honestly, whenever this was announced, I look up some pros and cons between them, and really there weren't any huge pros or cons. I think they're both solid projects, but it is cool that, you know, Cryo is doing it all in one, whereas Containerd requires another service called runc. And so that's, you know, I think it would be cool to try out. Although if you're already running a cluster with Containerd, I wouldn't say this is a huge deal and you should switch over. Yeah. It's just cool to have, like you said, Mitchell, more options available.
For sure. Yeah, it's just awesome to see more projects become CNCF graduates and reach like their standards for a mature project. We mentioned Flux last time and Argo CD last time. Those are also both CNCF graduates. If you've never looked at the list of their graduates, I think there's quite a few projects there. I think Kubernetes was the first one. Google actually like handed over control of the Kubernetes project to the CNCF kind of early on, and that really helped get the ball rolling with, you know, them being an impactful force in this space.
Yeah, there's tons of them. We'll link a list. They have a page with a list of all their graduated projects, incubating projects, and then kind of gives a rundown of when they consider a project graduated. So we'll post a link to that in the show notes.
Nice. So last show, we talked about GitOps, and we mentioned Terraform, not really in the context of GitOps, but in the context of an infrastructure as code tool. And over the past couple of weeks, we actually ran into kind of an intersection of those. Do you want to talk about that?
Yeah, so we have evaluated, you know, a couple different solutions here. GitOps is really cool inside of Kubernetes for deploying containers and deploying storage and all the secrets and things in Kubernetes. But I've always had this question of what if I need a bucket in, you know, some cloud provider, or I need something else like that that's kind of outside of Kubernetes, and there in the past hadn't been a great way to handle it. There's two tools we've found recently, actually. So first of all, there's Crossplane, which looks cool. It's all Kubernetes native, and you can request these objects. We had some questions with it. I think it didn't fit our use case perfectly. So I did some more research, and we found Weaveworks, who maintains Flux CD, have a Terraform controller for Flux. So you can actually manage your Terraform deployments in a GitOps fashion. And when you make Terraform code changes and push them, your Flux operator will pick up those changes in a separate container and keep the objects that are being created, like the bucket, up to date for you. So haven't tried it out yet, but it looks really like a powerful way to manage Terraform.
Yeah, so we evaluated Crossplane. We're actually using Crossplane in a couple different client environments. One of the downsides to Crossplane is it's just not as mature of a project as Terraform. Terraform's been around a long time. There are modules written and like integrations written for almost anything you can think of. I think there's one for like ordering pizza from Domino's.
Now you can do it with Flux.
Yeah, so that's really cool because we had started working on using Crossplane for some specific GCP resources, and not everything we wanted was fully supported yet or fully built out yet.
That was it.
And those things are already built in Terraform. So stay tuned. We'll be playing with the Terraform controller for Flux to see if that can bridge the worlds of Terraform infrastructure as code and GitOps via Kubernetes and Flux. All right, let's move on to our main topic for today, monitoring. Gabe, what do we mean when we say monitoring?
So monitoring is kind of overall information about like real time what's going on with applications you host and the platform as a whole. There's a difference between monitoring and observability. This is more about the monitoring side of things. But basically monitoring is kind of telling you that something is wrong, and observability is tying in more data to tell you what's wrong. So for example, I'm going to talk about in tools later, one that I've been deploying pretty heavily recently is Prometheus with Grafana, and it lets you, pull a bunch of data out of Kubernetes and create dashboards with graphs and tables and lots of data. But for example, with Flux CD, if you see a spike in CPU usage, and then the Flux, operator crashes, you don't necessarily know why. You could probably look at logs and figure out why, but if it crashed, you may not always have that data. So observability kind of ties in an additional component of like, what was Flux doing? So in Grafana, that's called an annotation. It'll add a little vertical bar that's like, hey, this is what I started reconciling. And then you could look at that and kind of know what was going on whenever it crashed or whenever it used a huge amount of CPU. So yeah, monitoring kind of leads to observability. And it also leads to alerts for, lots of things, service outages, service degradation, just anything possibly about to go wrong. There are lots of different things that you should monitor.
In an ideal world, you're going to monitor a service or a website or whatever in a way that emulates the consumers of that thing, right? So if it's a website, you want your monitoring to kind of mirror how a person would see the site or how they would experience the site. And if you're running some service that an API is hitting, you wanted to monitor things that the external service is going to care about, right? What's interesting is these aren't necessarily the first things you think of. I know, at least for me, the first thing I think of or used to think of related to monitoring would be how hard's the CPU getting hit? How much memory is being used? What's the disk space like? And while those are important things, your website viewer or your API that's hitting your service, they don't care about those things. They care about very different things. And there are 4 fundamental things that we can measure that indicates how our site or service is performing as if it was a user of that site. And these are called the 4 golden signals.
The 4 golden signals are 4 different type of metrics that kind of measure the most fundamental aspects of your service. It's especially helpful when you have large systems like many microservices or just many different services, because there's a lot of things that you have to look for that could possibly prevent an outage or just slowness. And so kind of having a top 4 can be helpful. So the first one is latency. And that's, when a user makes a request, usually over HTTP, how long does it take for them to actually get a page back? And you want to look at separate metrics for success and error. You want to know kind of how quick successful responses are and how quick error responses are. If these were together, then, a database going down is going to cause a pretty instant error. And that might happen a lot if a database is gone. That could bring down your overall latency. Whereas, if you have an error where something's not responding, that could take a long time. So it's useful to have those split up. So okay, when a user gets something expected, how long is that taking? Are we talking half a second, 5 seconds? And then whenever we get errors, how long do those take?
I just want to jump in real quick and say that you should monitor these things per application or per service, For one service, responding in 3 seconds may be acceptable. For something else like a page load, you want that to be like under a second ideally. So you should be able to kind of baseline whatever your site or service loads in under normal usage and kind of set your thresholds appropriately so that you know when something's out of the ordinary. Applying the same thresholds generically and globally, that's not going to be super valuable.
And at the same time, now that you mention it, a lot of tools will even show you different endpoints, not just services, but whenever a user is loading a page versus submitting a forum or something like that. There's also traffic. That's another golden signal. And in this case, this is, an overall count of page loads.
Yeah. And you want to watch, obviously, for big spikes, like an unusual amount of traffic to your site or service. But you also want to watch for big dips, compared to the baseline. That could also be an indication that something somewhere is broken. You may be experiencing an outage to your load balancer service or something upstream of your application. And so your application is, usage is trailing off, even though the application itself may be totally healthy. So something to think about is, keep an eye on big spikes up and big dips down.
That's a good point, because when I'm setting up alerting, I always think to add the spikes and I always forget about the dips. So that makes sense. Another golden signal is errors. And there's a few different types of errors, kind of ranging from easier ones to look for to more complex ones. So first of all, kind of the first thing you want to look for are explicit errors. And that, could be uptime monitoring, just look for a site going down, or kind of a metric for the number of HTTP 500 errors. And you would want a percentage for this. So you don't just know, okay, well, it might be fine if you get a few 500s, but if the service is 99.9% success, then you're probably okay. But if you have a big percentage of errors, then something's wrong. And then you also want to look for actual application errors, like in the logs or in some dedicated Prometheus endpoint in the app. And then there's also implicit errors, and these are a lot harder to detect, but still can be helpful. For example, if your site's sending a successful response, but the page is completely empty, that's not successful. Users will not see that as like, all right, everything's working as intended. But, again, this can be hard to detect from a metric side of things. You've got to look at the response size or a big spike in page size, either up or down, without like a code deployment change or something. And then another one that I've seen is kind of policy-based errors. And this one kind of factors into latency, I feel like, but sometimes, people will have some policy set where, okay, if a request goes over 5 seconds, consider that an error, because that's a long time when you're waiting for a web page to load and things like that. And the last golden signal is saturation. And this kind of tells us how full a service is. This, is usually looking at a lot of different resources like CPU usage, memory usage, disk usage, and even network bandwidth. You ideally want to set a target below 100%. A lot of systems, if you do testing on them, you'll find they can handle a certain number of requests, but like that last 10% when they are full are very slow, even if it's working. So you don't necessarily want to say just if it's 100% full. That also can give you an indicator early on, like if changes are happening very quickly and a disk is at 90% usage, it's good to know before it hits 100% and data possibly starts getting corrupted. And you want to emphasize the most constrained resource. So if you find a specific pain point or one that's hard to scale, then that's the one to look for early on.
Emphasis on the most constrained resource. A lot of times, and for a lot of systems, that can be memory. Memory, specifically like RAM, that's something that's not really able to be overcommitted. CPU can be overcommitted pretty well. Memory really can't. And a lot of times, once you get to, when you get to your memory limit in Kubernetes or Docker, the orchestrator will just kill that container. So with CPU, you can run something at 100% for a while, and that may be okay. It may be normal for your application. Things may start to get slow or throttled, but it will keep running. Whereas once you hit a memory limit, it will just get killed. That's one where you want to set your thresholds quite a bit lower than 100. You want to start detecting when your services are using more memory than they can pretty quickly.
And actually in a container world, that's not even the orchestrator. That's coming from lower level than that. It's usually the actual operating system sees that a process has some limit and kills it. In Linux, it's the, out of memory killer. It'll notice that something's wrong and it'll just, there's nothing you can do about it.
Yep. That one's pretty much out of your hands if you let it get to 100%.
Yep, definitely. Whereas, like you said, CPU is very spiky. So if you go over, your app might, lag out for a second on the server, but that's fine compared to memory. Or another one that's pretty important is disk. If you fill up, that's not good. So 2 different kind of methods I found that have been inspired by the golden signals while I was researching this are the red method and the use method. So the red method was made relatively recently by Weaveworks, the same people that kind of work on FluxCD and make that Terraform controller that I mentioned earlier. It's heavily inspired by the golden signals, and it's more geared towards microservice architecture. And red stands for looking at the rate, which is the number of requests per second, error, which is failed requests, and then duration, so the time to process those requests. And then the use method was created much earlier. I don't know exactly when, but I'm seeing mentions of it being used in like the 60s with airline type things. So it's more to measure the actual infrastructure, and it's looking at the utilization, so the percent usage for a resource, saturation, like we mentioned, kind of the number of requests in the system versus what you can handle, and then errors, again, the total number of errors.
So we talked about the application side of monitoring. Let's talk about the infrastructure side a little bit. This will provide a little more color to like your whole monitoring outlook. This will show you more than what the users see. It helps with, obviously like keeping an eye on infrastructure capacity in real time. It will help with knowing how to scale your infrastructure up or down. You don't want a bunch of idle servers. You also don't want a bunch of highly utilized servers where there's no headroom.
So at the node level, a lot of these are similar for actually in the containers, but it's good to have metrics at all the levels of things that you can manage. So we want to look again for CPU and memory usage. But at the node level, then we also want to look at Kubernetes like pod requests. So if you have a specific pod requesting a ton of memory, but not actually using it, Kubernetes will refuse to put other things on that specific node. So you want to make sure that those are fine-tuned to what's actually being used. Also, the number of pods. There's a limit, and different deployments of Kubernetes have different limits, usually around the number of 120-ish. I've seen lower, I've seen higher. So that's something to keep in mind. And then just storage of the node. Every container you're running will have an underlying image that gets stored on disk. So that'll take up space. You also have your log output and lots of other, just even operating system files will take up disk.
How about at the cluster or pool level?
At the cluster level, we're looking at the number of nodes available kind of contributes to CPU and RAM, but more, added together for all of them. And if you lose a node unexpectedly, you want to be aware of that. PVC, so persistent volume claim usage. Again, this is kind of disk related, but PVCs are a lot of times outside of a specific node. They'll be hosted externally somewhere. And it's good to know if they're filling up. Backing storage, slash, just persistence usage. This isn't necessarily at the node level. You could have, some external service that's managing this. And yet if that fills up, that's, again, a problem.
In theory, you could have a lot of PVCs, persistent volume claims, that aren't fully utilized, but in aggregate, the used space may start filling up whatever storage is backing them. Like, it could be AWS EFS, it could be any other kind of shared storage that you'd have.
That's true. I forgot to mention that. That could especially be an issue if you're hosting kind of a clustered storage system yourself that has thin volumes. I see what you mean. So if the claims are all pretty small, but the hosting disk is full, then they can't grow. So that makes sense. And then there's also the total just overall CPU and memory usage. We also want to keep track of logs. You want to centralize them because, in Kubernetes, if a pod restarts, you lose the logs for the previous run. So you want to ship those somewhere external where you can hang on to them for a longer amount of time, a more guaranteed amount of time. You also, not all apps provide metrics. And if you're shipping logs somewhere, a lot of times you can compute log-based metrics based on the log output. So you can sometimes fill in some details there. You will need to deploy an agent. There's tons of, a lot of the cloud Kubernetes deployments automatically use FluentBit or FluentD. We've also seen Promtail. Once you, deploy one of those and configure them, they'll pick up all the Kubernetes logs and ship them somewhere external for you.
Yeah, those typically run like as a daemon set on each of your nodes. Keep an eye on how much resources they use because they are a full container. We've seen some that use a lot of resources.
Yeah, that's a hard thing with monitoring. It can be heavy sometimes. So that's true. Then, it's useful to have a tool that can view them. And there's lots of native ones in the cloud provider you use. Google Cloud has cloud monitoring. AWS has CloudWatch. Grafana has one called Loki, which you can host yourself.
When you're monitoring things, you kind of want to look at a percentile. By default, in a lot of platforms, that's an average or like 50 percentile, right? The issue with sticking with the average is that's not going to show a lot of outliers. So, you could have some requests completing very quickly, but you could have a pretty significant fraction of your requests taking longer, and those will kind of get averaged out, and that's not ideal. So you'll see a lot of guidance to look at the 90th percentile or the 95th percentile, and that kind of depends on exactly what thing you're looking at and your service. I probably don't want to be looking at like the 99.9th percentile because that's going to show basically only outliers, and that's also probably not valid. But typically if you picture like a response time, like a list of response times, it'll kind of form a curve, like a bell curve, with a lot of or a few fast requests, a lot of medium requests, and then a few slow requests. And you want to monitor somewhere kind of on the tail somewhere so that you can get an early indication of when stuff starts to go wrong for some subset of your users. If you wait till the average is bad, then 50% of your users are already seeing that problem.
A good way to show percentiles I've found in a lot of these dashboards are with heat maps. Heat maps are they're pretty useful for this sort of thing. So it's like a 2D graph, and the x-axis, so the bottom axis, is usually time, and the y-axis on the left is normally the percentile. And this could be, like response time is a common one, or something else. And you have a grid of colored dots, and the color, will change depending on how many requests fit within that specific bucket at that point in time. So it makes it really easy to recognize, where your average utilization is. And if there's some unexpected change, you'll see, a big red dot on your heat map, and it'll stand out.
Yeah, it's a really cool way to see like concentration of how people are experiencing the site. It's fun to watch it change too, as as stuff happens.
Yeah, if you're getting a lot of requests to a service, it's fun. You'll see it. You'll see them change live, which is great.
Yeah, and it's a fantastic way to show what's fundamentally a really complex data set. You kind of use the human visual processing center to ingest a ton of data. So related to percentile a little bit is like, what interval are you monitoring? And kind of similarly, you'll see, by default, CPU utilization is measured in like a 5-minute average or a 1-minute average. That's a really long time in like processor time. If you think about how long a web request takes for your like web server or service to respond to, that's going to be on the order of milliseconds. So if you're measuring even at a minute granularity, milliseconds are a very small fraction of that minute, and that is going to get smeared. You're going to lose the spikiness that those requests are, and it's going to get smeared down to a much lower average generally, which can be fine. It's okay for big picture stuff, but you lose a lot of the detail.
You do, but then it also comes back to what I mentioned a minute ago, that monitoring is, monitoring backends are pretty heavy. They can take a lot of memory, they can take a lot of disk, and the more often you're scraping that data, the more disk space you'll take up. Things I've noticed are the standard kube metrics that you deploy in Kubernetes seems to only update once per minute. Prometheus, all of its exporters update 30 seconds by default. But like you said, Mitchell, for like CPU, that smears a lot of the spikes. If you have a huge CPU spike in a few seconds, that's still a concern, but you don't have that granularity.
Yeah. And kind of what interval you're monitoring also can depend on the service level objective of your service, the SLO. If you don't have a high service level objective, then slow requests, as long as there's not a lot of them, may not be that big a deal. So, don't monitor milliseconds if you're not guaranteeing milliseconds, right? You want to monitor kind of in line with what your objective is. You don't want to be too high above it. Don't want to be too far below it either. Otherwise, you're just monitoring for, no actionable purpose. And speaking of actionable, let's talk about alerts a little bit. Alerts should all, in my opinion, alerts should all be actionable. You do not want to see things that don't require a response. You also want them to be timely. It doesn't help if your alert is an hour late or, even 5 minutes. Depends on the service. You want alerts as soon as you can reasonably get them, and you want to make sure that everyone that like hits Slack or email or text message or whatever your alerting, like your notification platform is, warrants a human response to them. Because if you over alert, and this has definitely happened to us in the past, you get alert fatigue, right? If that Slack channel is pinging you every few minutes saying, "Hey, I've got another alert for you. I got another alert for you," and in the past you've had to engage on very few of them, you will just start mentally filtering that out as noise. You've made it noise at that point. So it's important to keep those channels as actionable as you can, just for the alert fatigue alone. In addition, you don't want to be pinging people after hours. Like if you have those alerts waking up engineers, you definitely want to make sure that those are things that a human needs to be involved in. And this kind of goes back to thresholds too. You can set alert thresholds so you can require so many alerts per time period. So a random one-off metric threshold exceeded doesn't trigger an alert. But if you have a certain number, like maybe you have 5 in a minute, that would. So you can kind of tune those thresholds to help with that alert fatigue a little bit if your app has the tolerance for a few alerts versus a lot.
So let's talk about the actual tools. And there's a lot of different ways to do this. There are more enterprise type deployments. There are a few popular open source ones, and then there are kind of managed ways to track all this data. So on the enterprise side, I've seen a lot about Nagios and Zabbix.
Yeah, I actually used Nagios when I worked at an ISP. They have a lot of tools specific to networking gear. We had a big display board of all of our core networking links, and it would color them based on utilization. So that kind of goes back to the saturation golden signal we talked about earlier. And Nagios supported an absolute ton of networking devices. I mean, we'd have really obscure stuff that we pointed at, and Nagios is like, "Oh yeah, I know exactly what that is. Here's all of its interfaces. Tell me what you want."
That's cool. So is it intended more as kind of a network level monitoring tool?
I think that's how it started.
I've also seen that Zabbix has some pretty good incident management, although I don't know. I haven't used it myself, so I don't know for sure. On the open source side of things, that's kind of where I live. So the main ones that I have here are Prometheus and then Grafana to display the metrics in Prometheus. Prometheus is relatively new, actually, but it seems to me aimed at Kubernetes, very, very native to cloud hosting. And it basically just slurps up as much data as it can. And it has a standardized metrics reporting format. So lots of kind of infrastructure tools all the way from your ingress controller to, any operator. Typically they support it. And even some apps you can, just create something in Kubernetes called a service monitor or a pod monitor. And then Prometheus will find it and start grabbing that data. And then usually you put Grafana in front of it. And that's how you get all the fancy dashboards and graphs and tables and heat maps. And I've been experimenting with it in my personal infrastructure, still learning, but I've been able to pretty quickly, I was impressed. It only took a couple of hours to add a ton of metrics to some of these personal projects that I've built and host in my cluster. And that was pretty cool. And then there are lots of managed ways to do this too. if you use, a cloud Kubernetes cluster, I'm sure that they have some sort of metrics backend. Google has cloud monitoring and cloud logs. AWS has CloudWatch, and I'm not as familiar with Azure, but they probably have some level of monitoring built in. Externally, there's also Datadog, AppDynamics, New Relic, Pingdom. I've used Datadog and New Relic, and both felt pretty similar. Similar to what I was saying with Prometheus. They slurp up all the data, and then you can pull it out into a dashboard later on.
Yeah, some of these managed tools can get kind of expensive. One thing to keep in mind as you're evaluating these tools and their costs, while they are very expensive, if you're at the size where you need a full-time person to manage your monitoring infrastructure, that cost breakdown may make a little more sense. I know some Nagios deployments, for example, there was someone whose full-time job was managing Nagios and then getting devices imported and tweaking all the settings and thresholds and things. It's just part of the calculation, kind of the business calculation you run of whether or not to start paying for some managed tool over rolling your own or using an open source tool and hosting an open source tool yourself.
That's true. Although, there's also a level of robustness too. You don't have another service that you're deploying that could possibly fail.
You saying that made me think of this too. You don't want to run your monitoring service or services on the same infrastructure that they're monitoring. Ideally, those should be separate, right? Like if the thing that's checking uptime is also down when your service is down, that's no good. You're not going to get that alert.
That's true. Especially, so that, I guess that's kind of a benefit to the managed ones. If you're going to have to deploy a separate Kubernetes cluster, then might as well just not deploy an entire separate cluster and use some service in a box.
Yeah, that's definitely kind of part of the cost benefit analysis you have to run when checking out these managed tools.
Mm-hmm. My kind of personal preference here has always been to try to use the cloud dashboard. If I'm hosting in cloud, because for Google, they actually have Prometheus. So I mentioned earlier that all your operators and your ingress controller and things can ship metrics data. And at least in Google, you can get that data in Google Cloud. And so if your cluster goes down, it's the data is somewhere else.
Yeah, Google's in particular, their cost for monitoring and logging is pretty reasonable.
Yeah, and it's really powerful. Those dashboards are pretty fun to work with, actually. And that brings us to some other things that I just thought I'd mention. This one's kind of tool related, but one that I've always thought would be fun to use is chaos engineering. The most notable example of this is Chaos Monkey by Netflix. The idea of bringing down services during a test, let's just kill one of these microservices and see how the entire service responds. So it always makes people anxious when you talk about it, but I think it's pretty cool that Netflix, when they made this in 2011, had a robust enough infrastructure, at least eventually, that they were able to run this and just kill services and keep on chugging along.
Yeah, and they'll run it like during the day, like on production during the day, not an outage window. And that's like the holy grail of an environment. It is scary to take offline production services in the middle of the day. But
yes.
if you can do that and survive and the service isn't interrupted,
doesn't report any errors,
right? Like then you've made it.
Yeah. And then there's also game day, which is similar to chaos engineering, but it's more on the people side. It's kind of to gauge the team's response, kind of in preparation for, some big event or some big failure. You can see how would my team react to, some massive outage. And I've read that a lot of tech giants use it. So that one I think sounds pretty interesting.
Yeah, that's interesting. Like to test the people and systems that, aren't the actual, the system's running the thing, but the system is supporting the thing. That's interesting. Yeah.
And test the processes too, that those people are following. Just another thing I kind of wanted to mention is synthetic user monitoring, which is the practice of monitoring kind of how your application reacts by simulating users. That usually is kind of associated with it feels like a load testing type thing, but it lets you, create automated artificial users that click around in your site, and you can kind of keep an eye on metrics and figure out how the site responds. So you can learn more about how it responds under pressure without actually having to cause 1,000 users to load up your site or something like that.
That sounds like a really good way to get an idea of where you should be setting some of those thresholds, for dashboards, but also for alerting in an app specific way. So you can tell like, ooh, this one service really hates when its CPU is above like 87%. And then you can start actually getting a little more proactive. So you don't have to wait for the latencies to start increasing. If you've detected some indicator that happens before that, you could alert on that indicator. So if you know that every time CPU goes above 87%, you're going to start having higher response times or errors, you could alert on the CPU metric versus waiting for actual impact to happen.
Yeah, you could alert on 80% then instead of
right.
Earlier I mentioned don't alert on 100%, and I think I said maybe try like 90% as an example. But if it starts having issues at 87, let's alert at 80.
Yep. Awesome. I think that's everything we wanted to talk about with monitoring. Thanks for listening. Our website is podcastascode.show. If you would like to suggest topics for us to cover or have feedback on topics that we have covered, send us an email. Our address is contact@podcastascode.show. Join us in a fortnight to discuss a real-world example of a highly available dual data center, dual cluster Kubernetes architecture.
Talk to you in 2 weeks.